Hello students, this is ISI 2020 MCQ solution. We are in the part 3. In the first two we have solved from 1 to 13. So now we will be solving from 14. So consider the sequence 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 5 obtained by writing 1, 1, 2, 2, 3, 3s and so on. So what is the 2020th number? So that was happened in 2020. So as I has a knack of doing this, so you can do your research on the year which you are giving in. Okay, so that will be beneficial. So the last position where the integer appears is 1 plus 2 dot 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 n. So this we know, n into n plus 1 by 2. So like n square by 2 plus n by 2. So this is the pattern. So now if n equal to 63, then 63 64 by 2. So this is giving you 2016. So the number of 64 appears on 64 positions. So like 2017, 2018, 2019 dot dot dot. This will go till 2080. So hence if we check it out the options, so 64 is the answer. So C is the answer to this question. Next one, 15. Let A equal to x1 x2 of 50 x. We are two sets are given. Okay, and then the total number of functions. So the total number of functions. For this we need to proceed now. Real functions. So what is the total number of functions if A belongs to B and if is an onto structure? So to define the increasing mapping of f, let A equal to this x1 x2 dot 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 x50 and B equal to y1 y2 dot 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 y20. This is given. So we must split the elements of A into 20 non-empty sets, non-empty groups. So 20 groups which are non-empty of consecutive integers. First group will be mapped to y1, second group will be mapped to y2, third group will be y3, in that way. So to place 19 different cases, so 19 on a 49 available structure. Okay, so hence 49, C19. His answer is 1. A. So number of complex roots in the given polynomial, which is x4 z5 minus z4 minus 1, which have a modulus of 1. So this is a solution such that mod z is 1. So we do not know w equal to z to the power 5. So mod w is 1. Mod w minus 1 is z5 minus 1. So this is z4 and that is 1. So we write this equal to e to the power I theta when minus pi less than theta less than equal to pi. So 1 equal to e to the power I theta minus 1 square. So 1 minus of cos of theta square and sine of theta square. So this is 2 minus 2 cos theta after applying the formula. So cos theta gives you half, cos theta gives you half. So theta equal to plus minus pi by 3. Now z to the power 5 equal to w e to the power I pi by 3. So z equal to e to the power, this is a plus minus I pi by 15 plus 2 pi in by 5. Obviously 0 less n less 4. Once we put it, so now z4 will be z5 minus 1, so e to the power plus minus I pi by 3 minus 1. So this is plus 2 I pi by 3 finally. So now e to the power 2 I pi by 3 equal to 2 e to the power plus minus 4 I pi by 15 plus pi I n by 5. So once it is been done, so plus minus 2 pi I by 3 equal to plus minus 4 pi I by 15 plus 8 pi I n by 5 plus 2 pi ki. Okay, so plus minus 10 equal to plus minus 4 equal to plus 24n plus 30k. So solving we get plus minus 1 equal to 4n plus 5k. So only two possibilities for n equal to 1 or n equal to 4. So n equal to 1, k equal to minus 1. So this minus 1 equal to 4 minus 5. So z equal to e to the power minus pi I by 15 plus 2 pi I by 15. Okay, so this is 2 to the power, just find it, 2 pi I by 3. In the other case, here k will be minus 3. So solving z e to the power pi I by 15 plus 8 pi I by 5. Okay, so e to the power 5 pi I by 3. So option number, so you can calculate this. So two possibilities. So number of complex roots are 2. Next we have a polynomial. Px is x to the power 2020 plus 2020 x square plus 2020 x cube minus 2020 into x square minus 20. Well, a lot of 2020s here. Okay, so first of all, if we see this equation, this has 0 real root. If you see this x minus 2020, this has 1 real root, x equal to this 1. This has also 1, no, this has 2. Power is even, so 2. So obviously total real root is 0 plus 1 plus 2, hence 3. Next one. Which of the following is the sum of an infinite geometric series structure? Okay, geometric sequence whose terms come in the set of 1 half 1 4 dot dot dot. So let a1 equal to 1 by 2 to the power n be the first term. So a2 equal to 1 by 2 to the power m be the second term of the series. So where 0 less than equal to n less than m. Then the common ratio of this progression is a2 by a1 is 2 to the power n minus m. So the sum is equal to, s is equal to 2 to the power minus n, 1 minus 2 to the power n minus m. So that is equal to 2 to the power n minus 2 to the power 2n minus m. So the difference of the denominator is odd. So we can take m equal to 2n and let n equal to 3. Okay. So then s equal to 1 by 8 minus 1. So 1 by 7. So the sum of the progression is 1 by 2 cube, 1 by 2 9, 1 by 2 15. So in that way, if we just proceed, then the answer will come. Solving is this. Okay.